So the example that we're going to use today is actually right out of Hexaly's documentation. It's called the prize collecting vehicle routing problem. This is a very difficult problem. And basically the premise here is we've got a bunch of vehicles that start at some depot and end at a depot. We're planning in advance. So we're giving them their schedules and then they're going out into the world. And we're trying to maximize the prizes or tips or payoffs that these vehicles receive when they get to their stops. And we may not service every stop. And so the question is like, which one should we service? What vehicles do they go to? And what sequence should they be serviced in? And you can, of course, look at Hexaly's documentation if you want more information about this particular problem and the code that goes with it. To adapt this to Nextmv, what I have done is started with a Nextmv routing input. So you can see here, I've taken just one of ours and sort of adjusted the inputs a little bit. So what it has is a depot location. So this is where all the vehicles start and end. This might be where we keep our fleet. This might be our warehouse, that sort of thing. It has stops, which are essentially service requests with locations attached to them. This is, of course, essentially random data, but each stop has a quantity. So this might be resources used or time used. And then where it gets interesting here is I've added a tip field. And this tip is essentially a payoff for a driver visiting this stop. And I have a range here, which indicates that it is uncertain. So I don't know what it's going to be in advance. This is where it diverges a little bit from the Hexaly documentation. And so we don't know in advance what the tips or the payoffs are going to be, but we're trying to create these plans a priori before the operational period. And then we have a set of vehicles, each of which has a capacity, and we may or may not use all of them. There's probably a fixed cost associated with each vehicle. So given that input, here is the actual Nextmv app, which we've put this Hexaly model into. And so the first thing that we do is we use the Nextmv Python library here to wire up the parameters in the input. So we take things like the random seed from the configuration. One thing that I'm doing that's slightly different here is I'm using a random number generator to generate those tips or payoffs in advance. And we're going to do what's called a scenario-based approach, where we generate a bunch of scenarios, and then we optimize each one of these using Hexaly, and then we choose the one that's going to be robust to all of the scenarios. So we're going to optimize a scenario, and then we're going to look at the expected payoff and choose based on that. And the combination of Hexaly and Nextmv makes it very easy to do that kind of approach. It's not the only kind of approach you can do here, but it is a nice and convenient one. And it's what we'll show today. We compute a distance matrix, we do some logging, and then we actually solve the model. This model class is where I've actually put the code from Hexaly's website. And so you can see there's just some pre-processing here. There's all the constraints for the model. And then finally, this is a very interesting part. We have 4 different objectives which we're trying to balance. So the first thing that I want to do is maximize the payoffs. So this is essentially selecting stops and the payoffs that go with them, the tips. I want to then minimize the vehicles that I'm using because there's a fixed cost associated with that. Then I'm trying to minimize the range in the payoffs for the different drivers. I want to sort of balance pay among the drivers, such that there's not a huge discrepancy where like one driver gets $10 and another gets 1,000. And then finally, I want to minimize the total distance that the vehicles have to drive. And Hexaly makes it very easy to deal with all these different objectives that I have in my business. All right. Once I've got the actual model code written, this is what it looks like inside of a Nextmv app. And so you can see here, I've got my app container for the model, and it has sort of images and so on associated with it. I can run my app. I'll do that by just cloning an existing run. And you can see it has all these locations which display in the output. I can add a custom visual to this if I want. I'm just going to click run, and I can run it for a duration of 5 seconds. Once I do that, you can see that the run is queued. It will be picked up by the infrastructure, and it will be running. It is currently running. And I'll get an output in a few seconds. I'm just going to load one. You can see the queued one here. I'm going to load one that I've already run. And so you can see this is a run that already went through the system. And it has information like how long it ran for and what was the size of the output. It also has all of these statistics over here. And these are things that I put into my JSON blob for my output in using the Nextmv Python library. And these are essentially KPIs that I care about. So things like what's the total route distance, or in our case, I care about what is the expected range on tips for the drivers. I can also get the result, which has the actual routes, the sequences of stops that the vehicles go on, and things like the Hexaly logs. So you can see here it's balancing the different objectives. All right, so that's just an individual run. The question here is, how do I deal with this sort of balancing goal when I'm dealing with some different scenarios that I've generated? And one way that I can do that is I can run a scenario test. And so I can go here and I can go into experiments and I can click new scenario, and I can define it and I can say, what are the inputs? I can give it different configurations or instances that I want to run, and then I can tell it the number of repetitions and create a scenario test. In our case, what we're doing is we're generating scenarios using the random seed on the model, and then we're selecting from all the different scenarios based on the one that's sort of most robust in some measure. So I'll load a scenario test where I've already done that. So here what you can see is a completed scenario test, which has done all the runs for me already. Those are all down here, and I can go into each one individually, and then I can look at aggregate statistics on this table at the top. And so I'm going to pull up the result value. So this is the total tips to the top, and then I'm going to put the expected range of tips here. I can see that in a tabular view, or I could switch this over to scatter chart and look at something like this. And here what I see is I'm one point down here, which gives me a pretty high scenario value, i.e. total amount of tips, and a pretty good range, i.e. a low range. So it balances them well. And so operationally, this might be what I actually use. But then the question is, how do I automate this? And so in order to do that, I create what's called an ensemble definition. And so inside of the infrastructure, I can essentially do the same thing, but have the infrastructure manage it for me. And I sort of run it the same way as a scenario test. I give it the instances and configuration to run, and then I give it a rule for selecting the best plan. And so in this case, what I'm going to do is try to minimize that range. Now, an ensemble run looks just like any other run, and I'll load one that I've already done here. So you can see it's got the run details on the left, the statistics on the right. The big difference is what it has done actually is run it a bunch of different times and then used that rule to select the one that I want for me. Other than that, it looks exactly the same, but I'm using the infrastructure to generate all of these scenarios and do the model selection at the end, or the output selection at the end.